Deep inside an organization's digital infrastructure sits the enterprise brain. Systems like the McBrain wiki run on massive databases, Amazon S3 for the files, DynamoDB for the index, holding the most critical knowledge a company possesses. But the way we interact with that knowledge has shifted, entirely different users. Letting autonomous software poke directly at raw database partitions is a security nightmare. Without strict oversight, one confused agent could leak sensitive HR documents to a marketing team or accidentally corrupt the primary index. The solution is an MCP, or Model Context Protocol, server. This acts as a strict, singular front door. Instead of touching the database directly, every agent must knock on this door, present an ID, and verify their exact permissions before they can read a single word. There's a glaring issue with this setup. In standard computing, when you force massive, simultaneous traffic to squeeze through one highly secure checkpoint, you instantly create a catastrophic traffic jam. To make these shared systems effective, the architecture has to reconcile two opposing needs: a rigorous, singular security checkpoint that somehow manages to handle a massive surge of requests without adding any visible delay. The McBrain MCP server physically exists as exactly one API gateway endpoint connected to a single AWS Lambda function. The microsecond a massive burst of AI traffic hits that solitary endpoint, the server triggers its primary defense mechanism. This is the fan-out mechanic. That single server dynamically shatters into 50 identical, isolated copies, instantly booting up to handle incoming requests. Think of a physical bank branch. Even with dozens of working employees, there is one bank building, one set of rules, and one master ledger. When a line surges, the bank instantly opens 50 identical windows. Any cloned teller can serve any AI agent simultaneously. This cloning mechanism resolves the bottleneck dilemma. It maintains perfectly uniform, centralized security rules, while applying them with massive parallel capacity. But that raises a new problem. If 50 temporary copies are rapidly processing complex permissions at once, how do they avoid accidentally leaking one user's HR file to another user's marketing bot? They do it through a strictly stateless architecture. Each one of these copies operates with total amnesia. It remembers absolutely nothing about the user it just served a millisecond ago. On every request, an agent's identity and permissions are rebuilt from scratch. The agent presents a token, unpacked to verify access. Once inside, strict triage applies. If an agent calls a read tool, like fetching a page, the clone fulfills it instantly on the spot. But for making a change, the server enforces a propose then merge gate. Heavy edits are shoved onto a separate background queue, called SQS, where different worker programs grind through them later. Combining perfect amnesia with extreme delegation, these 50 clones remain incredibly lightweight. They are impenetrable to data leaks and unbothered by massive traffic spikes. Eventually, the research tasks are completed. The burst of AI requests is successfully processed, and the traffic subsides. The moment the line clears, those 50 copies instantly evaporate back into thin air. Nothing is left running, which drops the server's idle cost back down to near zero. The operational impact here is massive. There are no permanent, dedicated servers for each separate team or tenant that an IT department has to constantly patch, provision, or maintain. Instead, this single, evaporating codebase securely manages thousands of unique users across countless different vaults simultaneously. It works because tenant separation isn't handled by physical hardware. It's enforced purely in the code, verified on every individual request. That 50-copy limit isn't even a hard ceiling. It's just a reserved floor built into AWS to guarantee interactive speeds. If traffic grows, the underlying S3 and DynamoDB storage scales entirely independently from the front door. The ultimate achievement of the McBrain MCP server is its invisibility. By utilizing stateless cloning and strict delegation, it achieves a highly sought-after goal in enterprise data management: a perfectly guarded doorway that manages to act as if it is infinitely wide.